Yeah, okay. Okay, great. I forgot to claim host, but I'm now able to record the session. So I'm asking about how you went along last week's content and whether you attended other mentor sessions. Anyone, like just a brief overview of how the week was and how you found the assignments, any challenges or anything before we proceed to today's work? Anybody? Yeah, it had a lot of refactoring, and but it was some good content on what what was the concept on last week's work? I don't remember well, but you did some things on
That
yeah,
that was the advanced Prisma, right?
yeah, sure. Where you talked about eager loading and how it helps us avoid the n+1 query issue. Talked about pagination. I'm trying to share my screen. So I hope you can see my screen. Everyone, can you see my screen? Okay, not yet.
It's still loading for me.
Okay, let me try and reshare. Let me just share. Yeah, let me just share that one window. How about now?
Yes, I can see it.
Okay, so great. So today we are going to look about authentication and security. And the two terms that really confuses me, but we've done something on them already. We have authentication and authorization. I don't know whether any one of you can differentiate between the two terms. Anyone?
Isn't one about verifying who the person is? So you authenticate the person,
Yes.
and then the other is about access. So authorizing this user to have access to this data.
Yes, yeah, it's all about authentication. You prove an entity or someone is what they claim to be. And then for authorization is that you check whether they have access to the resources that they are trying to access. And there are a few terms that relate also to security, to cybersecurity. In relation to this authentication and authorization, we have concepts such as zero trust concept, where you must verify that a person is who they claim to be, even when they are still logged into your system. For example, you implemented the issue of this, was it authentication, authorization? They really confused me. Authorization, when we were looking about password hashing, and then when we implemented login and logon. And then now, despite a person being logged in, we still need to verify whether they are who they claim to be and whether they have access to the resources that we have in our application. And look at an example in an application where, for instance, we have different roles. Talk about role-based authorization or role-based access, where let's say you have an admin, you have regular user, or let's say you also have a store owner if it's an e-commerce platform. I like giving that example because it's one that you can easily relate with. So for this case, a regular user only needs to access pages that they are allowed to access. That is the checkout pages, the product pages, etc. And then for a shop owner, they need to only access also pages that they are only allowed to. For example, uploading products in their shops. This could be a multi-user store where different users or different vendors could create stores. So each user should only access and upload products in their own shop. And then for the overall admin, they can now access the entire system. uh, Look at it in that way. And then, so when we talk about this authentication and security in context to our lesson today, we talk about these JSON Web Tokens and what they are. We'll talk about HTTP only cookies. We'll talk about cross-site request forgery protection. These are vulnerabilities that can exist in our applications where attackers can maybe forge a request to our application and access or sniff users' credentials uh, while pretending to be authorized users. And we'll also talk about now how we implement these out middleware. Apart from the one that you now had in your application where we are using the global.userid, now we'll talk about these out middleware which now replace the global variable with a real and multi-user session system. One problem that exists at the current implementation that we have with the global user ID is that you cannot implement multi-user sessions, and just another user can access tasks belonging to a user who is already logged in. So the system has no way of keeping tab which user is logged in. So that's a security risk that we'll address today. We have an example here of how we generate this authorization token. We'll be using the JSON Web Token for this, where we'll be generating a token that is, we'll sign a token and then set it in cookies, and then during request, we'll need to verify that this request has not been forged before a user can access resources or send any request to any route in the database. I hope I'm not moving so fast or I'm not vague in my explanations. In case of any questions, you can just ask. So we'll have the way we generate this, but let's first look at the concepts and we'll come back to this. So why this matters is that right now we only have one user who can be logged in at a time, and nothing actually proves. Okay, let me enter presentation mode so that you can see these better than hide this. Okay, great. So yeah, only one user can be logged in at a time, and nothing actually proves who is making a request. So real authorization is what turns these now demo apps into something you could put in front of real users. So these we are now talking about production security instead of now using the global user. So what we'll cover today, we learn about why authentication matters. We look at JSON Web Token, JWT. We look at HTTP only cookies. Then we look at cross-site request forgery protection. We look at the out middleware, and then we look at other security packages that exist. We'll talk about Helmet. We'll talk about rate limiting, and we'll talk about now sanitization, that is cross-site sanitization. And then we'll just look at your assignment preview. So by the end of these will identify that the issue and verify JSON Web Tokens, store them safely in HTTP only cookies, and defend against cross-site request forgeries, and protect routes with real auth middlewares. So just for a warm-up, I want you to think about a site you use that requires you to log in, and think about what happens behind the scenes or immediately after you submit your details in the login. So after you log in once, how does it remember you across requests, and what do you think happens under the hood? So just anyone to give a brief or what they understand with the login syntax or the logging background, whatever happens in the background, just anyone could just unmute and give these, sorry, anyone to unmute and give us what they do.
Login
Yes?
login credentials are set in database, so that's how
Yes?
it remembers.
Okay, yeah, okay, login credentials are set in database. I also hope that you remember we said we don't store these passwords as plain text. So anyone else that login credentials are saved in the database, but also keep in mind that for each and every request sent to the database, we need to verify a user is who they claim to be. So will you be verifying each and every time, or will how does after you log in, how is that information from the database saved to the front end so that it is the identity is attached to each and every request that you make to the database?
It's uh, it, it's doing it by authentication.
Yeah. Okay. Great answer. That's enabled by authentication. But let's now look at what now happens in the background. So keep this in mind that by the end of today, you'll know exactly what's inside that remember, what's inside that remember me mechanism, and you'll have to build it yourself in your assignments. So the two problems that we are fixing after this is that currently our app has two problems and both stem from the same root cause. That is only one user can be logged in at a time using the global.user ID, and anyone can access data as logged in user. So there's no real session. That's why I said any user can access other users' tasks provided one user is logged in. So both problems stems from using this global variable. So this week we'll fix this issue by implementing a real authentication system. One that proves on every request exactly who is asking or who are making these requests to the database. Let's just look at how these sessions now work, or what happens behind the hood of every login functionality. So when a user logs in, five things happen in a sequence. First is that the server verifies their email and password. We implemented these in logon and register functionality, where when a user was logging in, we hashed the password and then stored the hashed password. And we also emphasized on the importance on why we don't store plain text passwords. And then, so when a user logs in, first the server will verify their email and password. Then the server creates a signed token. That is, we'll talk about this JSON Web Token with the user IDs. So the token is sent back in an HTTP only cookie. So we'll also look at why we don't use browser storage or local storage instead, but use cookies to store this token. And then, so browser sends that cookie with every subsequent request. So, and number five, the auth middleware verifies the token on protected routes. We'll see how now this auth middleware verifies that this token has not been tampered with or forged. Also, a key concept in in this cybersecurity, you also learn that we have to protect data each and every time. So we have three areas in which we need to protect data. We need to protect data in actually two. We have to protect data in storage and data in transit. So, but we also need to ensure the users that their data is authentic and not tampered with. So this now GWT will help us now to verify that these requests are coming from the actual user who logged in the first place. So for now, after this, we'll not be using the global dot user ID to every request. Okay, so that was how the session worked. Now let's us look at what GWT is. So a JSON Web Token has three parts separated by dots. It has the header, it has the payload, and then it has the signature. We'll see on how we sign and how we decode this JWT token. So the header is the algorithm used now to generate this token, and then we have the payload, which now has the claims. You'll see that it will include the user ID, the expiry, and in some instance when where I was talking about this role-based authorization, it will have, let's say, the user role, and then it has the signature that proves that the token wasn't tampered with. So this is what will be verified each and every time we make a request to the backend. We have an important point to note here that anyone can read the payload. The signature is what makes it unforgeable. So that's one thing you need to keep in mind about this authorization. Okay, I don't know whether there are questions. Let me look at the, okay. Yeah, so someone had made a comment here about iterating on our app is annoying because you have to log in each and every time. Yeah, you see, these are no issue because when you stop your server, you lost the connection. Okay, I don't know whether there is another question, but that's the structure of JWT, the header, the payload, and the signature. And now when we talk about creating this JSON Web Token, so JSON Web Token signs a payload with a secret key and an expiration. So before this, you'll need to, okay, so let me reshare my screen. Again, I don't know what happened. Sorry about that. I hope you can see my screen. We are talking about now creating this JWT, but before you can create this, you'll need to have installed the JSON Web Token using npm install. And then after, let me enter presentation mode. And then after, yes, yeah, these are creating the JWT. Then after installing it is now when you come to create these in your application, that is in your user controller. So you'll have now to require this JSON Web Token. Then now to create the code, the token, you'll have the const token is equals to jwt.sign. And we've said that JWT now signs the payload because has three parts, and we sign the payload. JSON Web Token signs a payload with a secret key and an expiration. So we'll have the const token is equals jwt.sign. So this will be our, sorry. So this will be our payload. We'll have first the user ID, and then we'll generate the CRSF token for cross-site request forgery prevention using the crypto.random VID. And then you'll have stored now these GWT secret in your .env file, which will be a long secret, and then we'll use it to sign our token. That's why we need it in our .env file so that it's not exposed in our main code, and then it has this expiration, which now for our case, it expires in a single day. So an explanation here is that the JWT secret must be long, random string stored in .env and never used in your code. Never in your code. If an attacker gets your secret, they can forge any user's token. So you need to keep that in mind. And we have different sites that we can use to generate these JWT secrets. You can just search in your browsers for the JWT JSON Web Token generator. Yeah, you can just search for them. JSON Web Token generator, and then you generate a single JWT generator. You can search for any generator and then generate a single key. You can generate one for 64 bits, which is much stronger and not easy to crack. You can also use one for 124 bits, but one for 64 bits, it's enough. Don't know whether you can see my screen on the, or I'd shared a single. Can you see my browser? The one that I'm currently sharing now.
We can see the presentation, not the browser.
Okay, I was just sharing something on the browser on how to generate these. Let me reshare entire screen. Sorry for this. Let me share my entire window. Good. Hope now you can see. Hope you can see now my browser.
Yeah, we can see it.
So you can just search for this GWT generator and generate any random string. You can vary the length, but 64 bits is quite sufficient enough, because also look at the size of the data that your headers will contain. I don't want to dive much into issues with these cybersecurity or networking, but also the length of the data that we send or we attach in our headers also might impact the performance of our application. So if you send or if you send a very long headers with so much bytes, it can also implicate your the performance of your application. So a length of around 64 bits is enough, and can just generate any random numbers. So for example, we can generate this random number here, and you can just copy it in your .env file and include it as your JSON Web Token secret. Yeah, so just wanted to show you how to generate that. Let's move back to the slides. Yeah. So that's how we generate it. We include our payload for our case user ID, and then the CRF token, which we generate with a random string also using the random way. And then we'll sign it with our JWT secret, which we'll store in our .env file and include the expiration date. So that was creating. And now when we come to verifying our JWT, So gwt.verify throws if a token is expired. Okay, so is this? If a token is expired, invalid, or tampered with. So now it will just return the 4.1 error with the unauthorized message. For our case, when either of the three cases is true, expired, invalid, or tampered with, and now protects an unauthorized user or someone trying to sniff through our websites. Okay, yes, Lee.
I'm
See you.
curious,
Yes.
does the JWT.verify, does that use the CSRF token?
No, that one does not
Oh,
use the CRSF token. We'll come into where we use this token because we'll be using it to verify now write, delete, and update functionalities. That is before we tamper with or update any data or create any data in our database, we need to verify that these requests are coming from an authorized user. So that is where we'll use the CRSF token. But we'll come into that. So for verify, it just verifies that the token is not tampered with. Only that. Because we'll pass in the token and then the GWT secret from our .env, and then it will verify whether the token sent from the database is the same token attached to each and every request that are being sent to the database. I hope I've handled that clearly.
yes, I think so. Thank you.
Okay, yeah, you're welcome. So this one just verifies the token sent, and now it will generate the same way we just generated the token. We'll just generate an identical token to the one sent from the database, and then we compare whether they match. Because if it had been tampered with, we expect to get something different. Because now changing even a single string or a single character from this token makes it invalid and proves that it has been tampered with. So yeah, we use this so const payload is equals to jwt.verify. We pass in the token that we received, and we pass also the JWT secret from our .env, and then we can now extract the user, because remember while we were signing the token, we passed in the user ID here in the token. So we'll also need to extract these user ID so that we can use it in downstream or in subsequent requests or where we need to use it. Let's say, for example, when creating a task, we'll need this user ID so we can extract it from the payload. Look at the way we create the payload with the token with the payload, which now has the user ID, and the way we extract this user ID. So rec.user will be, we extract the ID from the payload.user ID, and then we call next, because this will now be used in a middleware. So we call next when this is verified, or next could be the next root handler. And then if an error arises, for which cases we've said whether the token is expired, invalid, or tampered with, we throw an error for the 4.1 and tell the user that they are unauthorized. So a successful verify means that the token is genuine from your server and hasn't expired. So that's what lets you trust rec.user downstream. Yeah, so that's it for the these two words really confuse me. For the authentication part, where we sign in the JWT and then we verify after each and every request. So, but I mentioned something to do with these HTTP only cookies, because when setting these or in your assignment, you'll see that you need to set this cookies flag. And then we have, I post a question or something on why don't we use local storage instead, because it's also an option, but we have this. So Why HTTP cookies? Where do you store the JWT token? So the choice has real security consequences. So for local storage, it is accessible by JavaScript and vulnerable to this cross-site injection, or any script can read it. So that's the main reason why we don't use this uh, local storage, and why we use the HTTP cookie, because it is inaccessible to JavaScript and is safe from XSS attacks. So the browser withholds it from scripts. Remember when you talked about, or when you were being introduced to Node, you also looked at the difference between browser side JavaScript, that is React, and the normal JavaScript and server side JavaScript. We said that they both work in a sandbox, like the browser only runs in the browser and has no access to your machine and file system. But now look at the vulnerability that can arise, because we have functions that you can run a JavaScript function directly from the app. We have the eval function, or also someone can inject some malicious scripts in these forms. So to protect that, or maybe they might try now to trick your browser to thinking, or to modify your request to thinking that it is a legitimate request to the database. So to prevent that, that's why now we only use these cookies, because they are not accessible to JavaScript. So the way we'll be setting the cookie is using the res.cookie, and then we pass in the token, the JWT token, and we pass these config options we have for HTTP only. We set it to true, and same site we set it to strict, sorry. And so for the maximum age of these, we set it to 1 day, just same as the expiration of our token. Yeah, expires in 1 day. So also this cookie, we need to set it the expiration to be the same as our token. And same site is that we restrict access from the same site, because you'll find that in most cases we find our backend and frontend runs in different URLs. So that's why we'll restrict this same site access. But also after this, I'll want you to look at another middleware we call Axios, or cause. That is a cross origin request. It now allows, or it's what allows these applications, the backend running in a different URL and the front end running in a different URL, to communicate. So that was setting the cookies. You set it using that. Yes, Lee?
When you say for HTTP only cookies, they're
Yes.
inaccessible to JavaScript, does that mean read only, or does it not even, can it not even read that cookie?
JavaScript cannot read that cookie, so it will only be used in the HTTP communication protocol, because we have different file transfer protocols. We have FTP, and then we have HTTP and HTTPS, which are hypertext transfer protocols. And then, so these are only, how can I put this? These are only used to communicate over the internet. So JavaScript cannot essentially access it directly. It's not executable code.
Okay.
Yeah, sure. So that's what we mean. It cannot read, it cannot modify the HTTP only cookies. They're just sent as a header. It just can't access them in any way, as opposed to the other one for local storage, which you can access with the local storage.get item, and then the name of the variable you stored in local storage, or local storage.set item. I'm sure you've interacted with the local storage API in React. Yeah, so that's setting the cookie and then now reading the cookie. So with cookie parser, so we'll need this middleware for cookie parser, and then the token is available directly on rec.cookies. So you'll need to call the app.use cookie parser, which will have installed with npm install cookie parser. And then the token is now available as a const token is equals to rec.cookies.token. Because when we were setting it, we gave it the name, this token. So the name token, and then we pass in our GWT token that we generated. So just reading it is const token is equals to rec.cookie.token is how you access it. So without cookie parser, you'd have to pass rec.headers.cookie manually, which is a fragile and error-prone string operation. So just require the cookie parser and access it directly from rec.cookie.token. So let's now talk about, I hope it was clear on those, the concept of JWT, what it is, and how we sign and how we verify a JWT, and also how we look about, or how we create the cookies and how we read them. I hope that's clear, and if there's any question on that, I can answer that before we look at the CSS RF attacks, that is cross-site request forgery. Any question or comment or addition? Anybody? Okay, so let's look at these cross-site request forgeries. But also remember, we have so many types of attacks. When it comes to cybersecurity, also we have the DOS, that is denial of service attacks. We have rainbow attacks that you've also interacted with. So for the cross-site request forgery, this is a malicious page that tricks your browser into sending a request to your app, and the HTTP only cookie, the HTTP only cookie goes along with it. Now, this hacker is able now to trick your application into believing that these requests are coming from a legitimate user. So we have an example of an attacker's page here. As I was saying, they can now they can now try to execute this, especially more so in form inputs, or they could send some code which have this malicious code. We've also talked about SQL injection, but for this one is excuse. For this one now, they just trick your browser to send this request to your application. This is an example of an attacker's page where we have a form, then the action sends into your application, tries to access the task with ID number 5, and the method is post. So they could now, let's say they want to modify or change the task or delete your task. For post actually, for post is now creating a task or just any modifications to the task. They can be able to do this through these CSSRF attacks. So the server can't tell if you sent this request or the attacker did. So the cookie looks identically either way. And so that's why we needed to attach or to create these CSSRF token. And now I'm going to answer the question on where you asked it is used. And I said that we normally use them when we are conducting or when sending requests that require us to modify, create, or delete data from our database. For those 3 requests, we need to verify each and every time. Okay. So let's look at this cross-site request forgery defense token. So we store a random CSSRF token in the JWT and require the client to prove it can read it. So what happens is that So return this cross-site request forgery token in the login response body and not in the cookie. In your assignment, you'll be required to implement this. And then frontend stores it in local storage. So for this one, we store it in local storage, but for the cookie, remember, we don't store it in local storage and we only use the HTTP only. And then, so frontend will now be sending it as a header on every write request. That could be the write, including delete, update, and create. That is post, patch, put, and delete methods. And then so the middleware checks the header. So header token matches the token inside the JWT. So how this now prevents this attack is that an attacker can make your browser send the cookie, but they can't read your local storage from their own page. So they can never get the CSRF token to send all along. Remember, or also at your free time, just look at how these attacks happen and look at the concept of man in the middle attack. So let's say this is where, for example, two devices are communicating, where this hacker doesn't essentially have to have access to the physical device, but they can intercept and eavesdrops on any communication between two devices. So for this case, for the man in the middle attack, which is the most often case, you see that they don't have now access to your physical device, so they cannot read your local storage. That's what that point at the bottom explains. Yeah, so that was it on these cross-site request forgery request. And in your assignment, you will need to implement it, and you'll have a better understanding when you're implementing it. So let's just look at, sorry. Let's just look at the auth middleware. That is the full version of it, and how now everything comes together for the verifying the JWT and then checking the CSRF token on write operations. Remember the other middleware that you had that was only checking whether we've set the global.user ID, but now we'll modify and come up with this JWT auth token. So for example, we have the module.exports. This is our middleware. We have the parameter request response and next. So we generate the const token is equals the rec.cookie.token, the one that we set in this. This now will be set in your, this token will be set in your user controller, but now you will also need to verify that it exists in the middleware. So you check whether the token is present using the rec.cookie.token. And if the token does not exist, you'll return the 401 error telling the user that they are unauthorized. And then we look at the payload. So in a try catch block, so we'll have the const payload is equals to gwt dot verify. We verify the token and then pass in also the JWT secret from our .env. And we extract the user ID. Rec.user is equals to ID, payload.user ID. Remember the way we set the token. So how to verify these CSRF check for write operations. So we'll have the const method is equals rec.method, and we'll check whether any of these is included in the method. We'll have if pass an array of the method that we're checking for. We have one for post, patch, and delete. But if we were using the put to update, we could have also included put in this method. So that includes the method and const. Now we check or verify the token. So const CSRF header is equals to rec.get. We get the CSRF token, and so if the CSRF token is not equal to payload.csrf token, will return the unauthorized message from the 401, that is invalid CSRF token, and now call next, which will handle the next root handler. And in the catch block, we just return also the unauthorized in case we are lacking this token. So this is how your auth middleware will look like. It might be a bit different from the one in the application, in your assignment. So another thing that we need to do is that also for the login, so we need to clear the cookie in the login and protect the logoff root itself with the auth middleware. So this is how you will implement it. You protect it with the auth middleware and also clear cookie with rest.clear cookie, and then you're clearing the token and send the message log off successfully. So the log off root is protected by auth middleware. So this prevents an attacker from forcing a log off, which could enable spoofing attack by tricking a real user into logging back in on an attacker controller flow. So for example, just naturally, if you're just using an application and it logs you off immediately, you'll need to log in back. So a user could be monitoring and just spoofing around the details that you put, and that way they could be able to access your credentials and access your account. We also you will also need to have a look at other security packages. At your free time, look at the helmet, which now you see that it also helps to guide our application against some known attacks by adding additional security and setting, I think, around 15 headers in our request that protect our application from some common attacks. Also look at the Express XSS sanitizer, which now sanitizes request body and URL to disable scripts. And also look at the limits and how they limit now request, especially blocking bots, because you will find that bots will display an abnormal behavior, which is if you compare the number of clicks per minute a bot could conduct and the number a normal human could conduct, that's now how these applications are able to detect whether one is a robot or an actual person. Because you'll find that a bot will send thousands of requests per minute or per second, but a user will have some sluggish because you need to navigate through the application and etc. I won't go much into this, but at your free time, look at helmet, the Express XSS sanitizer, and how we conduct the rate limit. I think I'll take questions, but yeah, I think I'll take questions, but when you're doing your assignment, you will notice that with this, okay, a minute. Okay, trying to look at your assignment. So when you're doing your assignment, you'll see that we might have a different, find the right assignment. Yeah, you'll notice that the way or the examples that I've used to take you through this, but the concepts are essentially the same, but now the examples will be a bit different, but employing the same concept. And how look at how you'll be setting now the cookie flags and also the set cookie method. It's essentially the same concept on what I've taught. And yeah, also now how you set these function for you'll use the callback for sending this for one error, which will also be a bit different from the example I've used, but they are essentially the same concepts. Yeah, so that's the only thing I wanted to bring into your attention so that when you'll be going through that, you won't get confused. I think I'll stop the sharing and maybe take in some few questions before we end the class. I hope I've not brought any confusion amongst you. Time for questions, takeaway, or any addition. Question anyone from our new members, but you can leave at your free time if there are no questions. Like, feel free to exit the meeting anytime. No question from Lee. So cookie still feels like dark magic. It's never exposed how cookies are. Yeah, sure. I think the one who now came up with the cookies just wants you to uh, know how they are applied, but never understand how they are created or how they work behind the hood. Yeah.
Actually, I do have one question.
Yeah, sure.
Um, so when I go into my browser, I think I can view HTTP only cookies. Is that right?
Yes, you can view it.
So, but for whatever reason,
Mhm,
code inside the browser
mhm.
cannot.
Yeah,
Do I
sure.
have that right?
Yeah, code inside the browser cannot because which example can you use? Take a look at it like, but this one is not a perfect example. Like for a PDF form, you cannot uh, modify it the way I send it to you unless you use other that party uh, text editors. But now for this HTTP, it's it's how they are transmitted or the protocol used in HTTP communications, especially when also you are dealing with HTTPS, which is has an additional security from the SSL certificate. So um, for for a user or maybe to try to send request using your cookie, they need to access it, read it, and then attach it to the request they're trying to make. So, and they need a code to read that. So, and we said, remember that this is only being read in your application. It is only being read and set from the backend, not the front end. So there's no way this person can modify it from and then attach it to a request, because if they try, it will detect that the signature is had been tampered with, and we've said the conditions that under which these HTTP cookies returns an error. It's when it is modified and when it has expired, or it is an invalid one. So reading it is quite difficult, but for you to get a better picture, and I'll discuss this in the next class, just try to look at the concept on how HTTP communication happens. And then maybe
Okay.
it will draw some light into that.
Okay. Thank you.
Yeah, okay, welcome. Any other question? But feel free to leave. I'll be the last person to leave the meeting so that I ensure that no questions are left or no one goes with questions in mind. Bye everyone. Have a good weekend too.